Hello, my name is Betül Araz and I'm a freshman industrial engineering student at Bilkent University. Today, in this video, I'll be talking about my PHYS102 lab project. In this project, I investigated the relationship between the initial height of a pendulum and the induced electromotive force EMF in a coil. Electromagnetic induction happens when a change in magnetic field induces an EMF, electromotive force, in a conductor. This principle leads to the inventions of many electrical devices such as transformers and electric generators. An electromotive force EMF is induced in a circuit if there is a change in magnetic flux through the circuit according to Faraday's law. The induced EMF in a coil relies on how quickly the magnetic flux varies through the coil according to Faraday's law of electromagnetic induction. To better understand this project, I want to introduce my equipment. We need camera, a pendulum, a coil, a magnet, a ruler, a copper wire, and finally an ammeter. After connecting a fixed coil to an ammeter, I prepared a pendulum with a magnet attached to its end and placed a ruler next to the pendulum in order to measure the initial height, and positioning the pendulum at three different heights, which are 10, 20, and 30 centimeters. In the first clip, you can see that I'm putting the pendulum at 10 cm and then releasing it, letting the pendulum to swing, passing through the coil, and recording the ammeter results by using a slow motion video analysis, and measuring the peak EMF value. And I repeat the previous steps for 20 cm and 30 cm. And I also record and compare the EMF values for different heights. After doing these experiments, I collect the EMF data to this table, and in the second table you can see the average EMF values. And in here you can see the error percentages that I found by using the experimental and theoretical EMF values. And here is the table that you can see the relationship between initial height and induced EMF. The induced EMF increases as the initial height increases, according to Faraday's law. To conclude, in this experiment, the relationship between the induced electromotive force EMF and the initial height of a pendulum is analyzed. According to Faraday's law of electromagnetic induction, it can be examined that greater first heights led to higher velocities of magnets, which cause a faster change in magnetic flux and therefore a higher induced EMF. The experimental results showed a strong correlation between greater heights and higher induced EMF, confirming the theoretical predictions. However, significant differences were seen between the experimental and theoretical outcomes, with error rates between 15% and 17%. These variations can be explained by timing inaccuracies, air resistance, or miscalculating both for mechanical and height measurements. Even though there were some certain experimental limitations, the overall results confirmed the theoretical model. The experiment also highlights the crucial role of precise experimental planning and collecting the data carefully in order to maintain accuracy in exploring electromagnetic induction. Future advancements can be done by using automated release systems in order to minimize measurement errors. Thanks for listening.